This is hypothesis test for population proportion. So this one, in this case, we're not testing for a mean, we're testing if the proportion, the average proportion that have some quality is what we assumed it to be. So the Regina Police Service claims that 3 out of every 8 drivers, 3 out of 8, that's a proportion by the way, right? Just so you know, 3 divided by 8. By the way, again, just like before in all my other videos, alpha is equal to 0.05. So 3 over 8, that's going to be, well, I wish I could do that in my head. 3 divided by 8, this is equal to 0.375. So that's a proportion, right? 37.5% of drivers exceed the maximum speed limit by 10 kilometers an hour. A sample of 1,000 drivers' speeds is recorded along various roadways in Regina. Of the recorded 1,000 drivers, only 340 drivers were exceeding the maximum limit. Is there sufficient evidence to refute the police service's claim? Okay, so in this case, I just want to make it clear though, the sample of 1,000 means we're going to have a large sample size. But anytime we're dealing with proportions, we're going to limit ourselves to just Z values because I don't really want to get into the T formula for those things. And by the way, here's the statistic you're going to be using right here. So you notice we need to find that P hat value. Well, that's just the sample proportion. So out of that 1,000 drivers speed, or out of those 1,000 drivers, 340 of them were exceeding the maximum limit. So P hat, which we're going to use in a bit, I just want to make it clear where I'm getting this from when I start to use it, is 340 divided by 1,000. So this is going to be the hypothesized value, and this is going to be the one that was sampled. So 340 divided by 1,000, this is equal to 0.34. Okay? All right, so let's work with this. H naught, the null hypothesis, we're going to assume that P is equal to 0.375 because that's the proportion that Regina Police Service is claiming that people exceed the maximum speed limit. And we're going to test that claim. So that's what we're going to put there for the null hypothesis. Step 2 was the state the alternative hypothesis. H1 was that, well, is there sufficient evidence to refute the police service's claim? You know, I think in this case, it doesn't, what we're trying to do is we're just trying to test if they exceed the maximum speed limit by 10 kilometers an hour. Now, they'd want to know if they go even further, but in this case, we're just going to make the assumption that P is not equal to 0.375. You know, they don't care if, they really just want to know if they're right. They don't really care if they're higher or lower. You could make an argument either way. You know, I won't penalize you if you set it up. What I care the most about for my Stat 202 students is if you are doing the right process. So whether you set this as a 1, as you know, not equal to, greater than, or less than, as long as you have some good rationale for it, I'm okay with that. So long as the work's correct after that. And what I mean by that is when I get to step 3, which is determine the rejection region, I have to pick if this is a 1 or 2-tailed test. I'm going to give you 1 second just to think about which one it would be. It's a 2-tailed test because of the fact that this is not equal to, right? 1 is if this were less than or equal to. But 2-tail is when this is is just strictly not equal to. We don't know if it's less than, we don't know if it's greater than, just not equal to. And fortunately, everything here is a Z test. Fortunately for us, it's all a Z test. But we have 2 rejection regions, and now this is where we put Z alpha over 2, because we have Z alpha over 2 here, and we have negative Z alpha over 2 here. Well, we still only care, and all we need to know. So the thing to keep in mind here is that because alpha is 0.05, this 0.05 is split between both of them. Okay? So we have alpha over 2 on each side. So this should be equal to 0.025. In other words, what that means is this region in here is 0.4750. Okay. So we look on our chart and we have to figure out what's the Z value that gives us that. Well, we find 0.475. 0.475 was right here because I'm using the same formula sheet as an earlier problem. This corresponds to 1.9 and 1.96. So Z alpha over 2 is equal to 1.96, and of course negative Z alpha over 2 is equal to negative 1.96. So if it lies above 1.96, when we get to step 4 and we figure out the test statistic, if that test statistic lies above 1.96 or it happens to lie below negative 1.96, then we know we have to reject. Okay, so now we do the test statistic. Where's my formula sheet? The formula sheet says, okay, Z is equal to P hat minus P over PQ over N. Now, anytime you see this Q value, anytime you see a Q on any of this stuff, it always just means 1 minus P, by the way. So if P is equal to 0.375, then that means Q is equal to 1 minus 0.375, which is going to be 1 minus 0.375, probably 0.625. Yes, it is. 0.625. So let's copy the formula down and work through it. So it's this formula right here. You should have your sheet in hand when you're doing this stuff so that you understand, or so that you can follow along. Z equals P hat minus P over the square root of PQ over N. So let's figure this all out one step at a time. P hat is 0.34 minus 0.375, okay, divided by, all right, I'm going to make a big thing here just so that we can fit it in, 0.375, 0.625, okay, all over N. So let's just figure that bottom term out. 0.375 times 0.625 divided by N. Well, N was actually equal to 1,000. Right? We know that N was equal to 1,000 because that's how many people we sampled. That's how many speeds we recorded. So we're going to divide that by 1,000. Right, let's make sure I'm doing that the right. 0.375 times 0.625 divided by 1,000. It's a small number. So this is equal to 0.000234, let's say. I'm including more decimal places here because I just want to make sure I capture the extra digits to make sure that I'm as correct as possible. So 0.34 minus 0.375 is going to be negative 0.035 on top, divided by 0.0002344. And I'm getting, oh wow, negative 149.3. My goodness. So what that's telling me, let's use a different color here. We'll use red. That's like way down here. Negative 1.49. I think I did everything right? I didn't make any silly errors. I don't think I did. Oh, you know what? I didn't square root it. Sorry about that. Made a little silly error. So this should actually be the square root of this number. So it should be 0.035 negative divided by 0.0002344 square root equals. Okay, so that changes it a little bit, but not significantly. This is negative 2.29. Well, you know what? If this is negative 1.96, negative 2.29 is still going to live down here in that rejection region, right? If I were to draw this out, the rejection region's over here, right? This is equal to negative 1.96. So again, like if you've been watching my other videos, unexcitingly enough, we reject the null hypothesis with 5% chance. And this is just sort of politeness that you're including this, just to say that, this is math, but don't get too confident, because in statistics, there's always flaws. They're only some percentage certain. So reject the null hypothesis with a 5% chance of type 1 error. It's saying, I'm pretty confident, but hey, I could be wrong. In the real world, you'd actually do a ton of different statistics on a lot of data. But here, we do our best. So there is sufficient evidence. You have to be careful about the wording here. There's sufficient evidence to suggest that the true proportion of speeders, of people, we got to be careful here, people who exceed the max speed limit by 10 kilometers per hour is different than 0.375. Okay? Or it differs from 0.375. Again, when you're trying to refute a claim, you're just trying to refute the claim. Well, I guess you know what they say at least. So maybe this should have been a one-tailed test. So yeah, this one actually probably might have been better as a one-tailed test. But you know what? Two tails works just fine. I'm not too worried about that. But just make sure that you word things correctly. When it's a two-tailed test, you're just saying that it's different from that number. You're not saying it's more, or you're not saying that it's less than. You're saying that it's different. So depending on what you want to show is going to kind of pick which direction you're in. Okay, thank you. I'll see you in difference of population means questions.